Exercise 5.1 Continuity and Differentiability. Third question, examine the following function for continuity. So we have solved three questions, A, B and C. This is the fourth question and we have to check the continuity here. F of x is equal to modulus of x minus 5. This is a modulus function. Why it is modulus? When you have two straight lines here. So when you have a two straight lines and you have a variable, then it is a modulus function. So in the class 11 we have studied about the modulus function, but we will revise it once again. Why we have to revise it once again? Because we have to change the format of this function. So here I have written f of x is equal to x minus 5, modulus of x minus 5. See, what is the basic function? What is the basic function here? The basic function was f of x is equal to modulus of x is equal to x if x is greater than or equal to 0 and modulus of x is equal to minus x if x is less than 0. Okay, I'll suggest you to put brackets here so that we won't go wrong when we are solving this sum. So this is the basic function, right, from which we derive the other modulus function. This is like a parent function. Now let us take the function that is given to us, modulus of x minus 5, right? So in the place of x, we have x minus 5, right? Same two straight lines here, same two straight lines here, but in the place of x we have x minus 5. So wherever there is x, we have to replace it by x minus 5. So this will be equal to, in the place of x we will write x minus 5 if, here we have to do some change, that is x greater than or equal to 0. So I am writing here x greater than or equal to 0. So in the place of x we have to write x minus 5 greater than or equal to 0. On simplification you will get x is greater than or equal to 5. So here you will write if x is greater than or equal to 5. Okay. Next, minus of, put the bracket. In the place of x we will write x minus 5 if x is less than 0. So x is less than 0. So in the place of x we will write x minus 5 less than 0. On simplification x is less than 5. So here we will write x is less than 5. See, this was the function they have given, but this is what we are supposed to write. Okay, so that the further steps will be easy for us. We will just do a small simplification here. We'll write this once again. F of x is equal to modulus of x minus 5, which is equal to x minus 5 if x is greater than or equal to 5. So let us simplify this, minus of x minus 5. Now if you multiply the sign here, this is going to be minus x, this is going to be plus 5. This is same as writing 5 minus x, both are same. 5 minus x. So in the place of this we will write 5 minus x if x is less than 5. So now this is our function. So whenever you have modulus function, take the parent function and substitute whatever they have given in the place of x, but you have to modify and simplify this part. Okay, so let us revise what we studied in the class 11. See here, now in this we call this entire part as domain. So whenever I say domain, you should know that we are talking about this inequalities, this part. Okay, and function. So when I'm saying function, you should know that this is what we are going to discuss. So this part is called domain and this is called function. Okay, and here, unlike in other problems, there was only single domain. There was only one domain, like real number, natural number, integer. There was just one domain. But in these types of question, you have more than one domain. So let us see what is that more than one domain. That is, we will break this. Okay, so one domain is going to be x greater than 5. One more domain is x equal to 5. And one more domain is x less than 5. So here we have 3 domains. Okay, now we have to check continuity in this and in this. Separately we have to solve. So whenever you have any question or any function of this type, you should break the domain into how many possible they have given. You have to solve in that. Sometimes you'll only get 2 cases, sometimes you'll get 3 cases. So in this we have got 3 cases. One is greater than, equal to and less than. So now we have 3 domains here. Okay, now what are the 3 domains? Have 3 functions. So what are the 3 functions? So if x is greater than 5, the corresponding function is x minus 5. So this is the corresponding function. And if x is equal to 5, here they have given equal, so the corresponding function will be x minus 5. And here they have given x lesser than 5, the corresponding function is 5 minus x. So this is the domain. Now these are the corresponding functions. So when we are solving the problem, if I am discussing about this domain, you have to check with this function. If this domain, then this function. And if this domain, you have to use this function. Okay. Now here, now let us consider this line as a domain, and I have infinitely many numbers on this, and one specific number which changes the game of the function is 5. So I'll write 5 here. Now if you move towards the right side of this number, here the values will be x greater than 5. Like you'll have 6, 7, 8, 1 lakh, 1 crore, like that. So all the numbers on the right hand side will be greater than 5. So this domain is here, greater than 5. And in this problem, in the place of x, I'll be using c. So c greater than 5, it is here. And the function that we use to solve this will be x minus 5. Okay. Now the second domain, x is equal to 5. This is just a point, x equal to 5. In this domain there are many numbers, right? You don't know which number to consider. All the number that is greater than 5 will be considered here. But in the second domain, it is an exact value. It clearly indicates that the value of x is 5. So here we will take c is equal to 5. Okay. In the third domain on the left hand side, x less than 5. So less than 5, you will get 4, 3, 0, minus 10, minus 20, minus 100. All these numbers will come in the left side of 5, that is x less than 5, but we will write c less than 5. Okay. So the first domain is here, second domain is the point, and the third domain is the set of many real numbers, infinitely many numbers. So we have to check the continuity in this domain, we have to check continuity at this point, we have to check continuity in this domain. So that's what our question was, right? you have to check the function for continuity. So you will check the continuity in three parts: 1 greater than 5, at 5, less than 5. Okay, so to check continuity, greater than 5 and less than 5 have same method. Same method you can follow. There will be same method to solve for greater than 5 and less than 5. But to solve at x equal to 5, there is a little different method that I'll be explaining. Now let us solve this sum. Now we know how to write f of x. So f of x is equal to modulus of x minus 5, and this is equal to, so how we have to write, this is x minus 5 if x is greater than or equal to 5, and this is 5 minus x if x is lesser than 5, and the domain here is the set of all real numbers. You can give any real number to this and you can solve. Now let C be any real number in the domain. Hence, we have three cases. So what are the first case? We have C greater than 5. Second case, I'll first solve for greater than, less than, and the third case is C equal to 5. So now you know how you got these three domains, right? Because of this. So directly you can write this in the examination. Now this will be the case 1, case 2, and this will be the case 3. Case 1, C is greater than 5. Now we will check whether the function is continuous when C is greater than 5. So what is the condition for continuity in that domain is, when limit x approaches C, f of x is equals to f of C. So this case will be used for both 1 and 2. So here we have to first find LHS, we have to find RHS, we have to check whether they both are equal. Okay, that's what I have written here, LHS and RHS. So first we will solve for the limit. It is limit x approaches C, f of x is equal to, first we will solve LHS, limit x approaches C. So which function value we have to take for this domain? That is x minus 5, and this is equal to, now this is a polynomial function, limit x is at every point, so we can directly write C minus 5. In the place of x we can write C minus 5. So when you are writing, don't write limit here. So now we got the LHS. Now let us solve for RHS. To solve for RHS, first we will see what is the function, how the function is defined. For C greater than 5, it is x minus 5. So this implies f of, if the input is C, any number that is greater than 5, then the output will be C minus 5. So here LHS is equal to RHS, right? Therefore, limit x approaches C, f of x is equal to C minus 5, and that is equals to f of C. So these two are equal, LHS is equal to RHS. So what we can write here, therefore f is continuous, f is continuous at all real numbers, all real numbers greater than 5. Greater than 5. So we have to prove continuity, and we proved it in the first domain. Now let us go for the second domain, which is case 2. So case 2, they have given C lesser than 5. So all the points that is lesser than 5. The same thing we will write f is continuous when C is less than 5 if limit x approaches C, f of x is equal to f of C. We'll prove LHS and RHS. We'll see whether they both are equal. Limit x approaches C, f of x is equal to limit x approaches C. Now C less than 5. So which function we have to take? We have to take 5 minus x. Okay, now this is a polynomial function. So limit exists. So therefore we can write 5 minus C. Now let us check the RHS. So to check f of C, we will first write what is f of x. F of x is 5 minus x. So this implies in the place of x, if we write C, f of C will be equal to 5 minus C. So now they both are same. So what we can write here? Therefore, limit x approaches C, f of x is equals to 5 minus C, and that is equal to f of C. Therefore, f is continuous at all real number less than 5. So to prove continuity, we solved in the two cases. Now we'll go for the third case, that is C is equal to 5. C is equal to 5. So to prove this at a point, this is not greater than 5, less than 5, this is equal to 5. So when you have to prove continuity at a point, there is a specific condition. So let us go through that condition here. So if you want to prove a function which continues at a point, at any point like 5, 6, 4, anything, at a particular point, then the same condition will be there. LHS should be equal to RHS. But for this limit, for this LHS, you have to prove that left hand limit is equal to right hand limit. So in my previous videos, I have explained about left hand limit and right hand limit. Okay, so in this case, you have to check both the values. If they are equal, then limit exists. If they are not equal, then limit does not exist, the function is not continuous. Okay, if both the limit exist, this also exists, LHS also exists, and then you check whether RHS also exists, and if they both are equal, then they are continuous. Okay, so first we will find left hand limit, right hand limit. We'll solve for this value, and then we'll solve for the f of C and check whether they both are equal. Okay, the first one is the left hand limit. Left hand limit, that is limit when x approaches 5 minus f of x is equal to. So x approaches 5 minus means 5 from the left side. So from the left side, if you are approaching, so which function you have to take? If you are approaching the function from the left side, so if you are approaching from the left side, you have to consider x less than 5. That is, you have to consider this function here, less than 5. If you are approaching from left, you have to consider this function, because here x is less than 5. So here you will get limit x approaches 5 minus from the left. So the function will be phi minus x. Now this is a polynomial function, so limit exists. So you will write phi minus phi, which is equal to 0. So the limit value is 0. Now let us check for right hand limit. Okay. So right hand limit. So you're approaching phi from the right side. So if you're approaching phi from the right side, at this place, what is the function that is defined? The function that is defined is x minus phi. So at this place, the function defined is x minus phi. So how do you write this one? Limit x approaches from the right, f of x will be equal to limit x approaches phi plus. So in here you have to write x minus phi. So it's a polynomial function, so limit exists, so directly you can write phi minus phi is equals to 0. So left hand limit is equal to right hand limit. Left hand limit is equal to right hand limit. You can say that the limit exists and the value is 0. Now we have to check for the RHS part, that is f of c. So f of x is equals to x minus phi here, because at c is equal to phi, how the function has been defined? When c is equal to phi, it is x minus phi. So we will write x minus phi, and in the place of x, if we substitute c, it is going to be c minus phi. But we know that it is phi here, so we will write f of phi is equal to phi minus phi, which is equal to 0. So we got LHS is equal to RHS. That is when limit x approaches c, here I'll write phi, x approaches phi, f of x is equal to f of phi. So f is continuous at c equal to phi. So we proved left hand limit equal to right hand limit. So therefore, okay, this exists. We also checked the functional value. This was also 0, this was also 0, right? So therefore we came to know that at c equal to phi the function is continuous. So now we proved this given function is continuous at 1, 2 and 3 in all the 3 cases. So what is the final conclusion? That f is continuous in the domain R. So in this entire domain, which we divided into 3 parts, in all the 3 parts it is continuous, so therefore it is continuous in the entire domain.